In the infinite expanse of the night sky, there's a star that's captured the attention of scientists and stargazers alike, Betelgeuse. It's a colossal star, hundreds of times larger than our Sun, and it's showing signs of something extraordinary about to happen. Scientists have been closely observing the mysterious dimming of Betelgeuse, and they believe it might explode in a spectacular event that will light up the sky across all nearby galaxies. This cosmic event, known as a supernova, could be an awe-inspiring sight visible even during the day. Are we about to see something new in space that will change how we see the universe forever? Join us as we explore how the Betelgeuse explosion will take the night sky all over the world. Betelgeuse, a prominent star in the constellation Orion, shines brightly in our night sky, positioned about 650 light-years away from Earth, which translates to approximately 6 quadrillion, 150 trillion, and 650 billion kilometers. Just to give you an idea, a quadrillion has 15 zeros. It's categorized as a red supergiant, belonging to one of the universe's largest and most massive types of stars. Its immense size dwarfs our Sun, making it a stellar giant of unmatched proportions. Betelgeuse's peculiar behavior and unique traits have captivated astronomers and stargazers for centuries, leading to numerous observations and studies that continue to mystify and inspire. Scientists believe it might explode in a spectacular event that will light up the sky all across the world. Considering the vast distance, when we observe Betelgeuse, we're essentially looking back in time due to the finite speed of light. Despite light's incredible speed of about 300 million meters per second, it takes a considerable amount of time to travel through space. In Betelgeuse's case, the light reaching us today started its journey over 6 centuries ago. This makes a fascinating puzzle because the things we see happening in the night sky actually happened many centuries ago. The light we currently perceive from Betelgeuse embarked on its journey towards Earth during the time of the Renaissance era. With each observation of Betelgeuse, we're essentially exploring a cosmic time capsule, allowing us to uncover the story of a star from centuries ago. The stage is set, and Betelgeuse is firmly in the cosmic spotlight. But wait for the most interesting part. Betelgeuse's sudden dimming caused a stir among observatories worldwide. This intriguing event took place from October 2019 to early 2020, posing a puzzling mystery that had astrophysicists and skywatchers searching for explanations. Known as the Great Dimming, it wasn't a subtle change. Rather, it sharply contrasted with Betelgeuse's usual brightness. Even to the naked eye, those who observed the night sky could see the difference. This unexpected transformation raised fascinating questions about the star's current condition and its fate in the universe. The main question on astronomers' minds was whether this dimming signaled the expected supernova explosion that had long been anticipated for Betelgeuse. Red supergiants like Betelgeuse are famous for changing how bright they appear. Scientists think this change is just a normal part of their existence. But something really big happened when Betelgeuse got dimmer than usual. People in the science world heard about Betelgeuse losing its brightness mysteriously. This got scientists thinking up different ideas. Some said maybe a huge flow of gas and dust from the star's surface caused this dimming. They pictured the star going through a lot, throwing off its outer parts in a huge show in space. Others thought there might be a very cold area on Betelgeuse's surface. They imagined a spot where temperatures dropped a lot, making the star less bright. While all this was going on, a bunch of scientists from different places, led by Kenichi Nomoto at the Kavli Institute, started looking into it. They found something amazing. They said Betelgeuse might be smaller and closer to Earth than we first thought. They also said a cloud of dust might have caused the dimming. It seemed like the universe had more surprises than anyone guessed. At the same time, astronomers, led by Hideyuki Sayo at Tohoku University in Japan, had a new way of looking at Betelgeuse's steady pulsations. This star seems to have its heartbeat, getting bigger and smaller over time, and changing how bright it looks. Its brightness goes through a pattern every 420 days because its outer part keeps getting bigger and smaller. As the big cosmic show of Betelgeuse unfolded and its brightness went back to normal, it left the space experts and skywatchers scratching their heads. Instead of giving answers, it raised more questions about what might happen to this amazing star. During this time, Betelgeuse got a bit cooler, and scientists found something similar to sunspots on our Sun. These star spots on Betelgeuse might have caused the temperature to drop. They're chilly areas on the star's surface that do some strange things to how much light it gives off. Just like how sunspots affect our Sun, these colder spots on Betelgeuse, in its magnetic field, could mess things up. Changes in Betelgeuse's magnetic field, caused by these star spots, might have blocked some of the radiation coming from the star's core. That's probably why the temperature went down when it was dimming. These discoveries about Betelgeuse aren't just about that one star. They give us a big understanding of red giants, which are these super huge stars known for making a lot of stuff in the universe. Stars like Betelgeuse are like giant factories where elements heavier than helium get created. Astronomers call these heavier elements metals, and how they form in red giants is a really important process. It's a big deal because this process shapes how everything in the universe is made up chemically. Understanding how star spots affect temperature changes and block radiation helps astronomers get what's going on inside red giants. When Betelgeuse got dimmer and cooler, it made astronomers share lots of ideas and theories about what might be happening there. And get ready, because there's a big discovery that's about to shake up everything we thought we knew about this massive red star. But for now, let's focus on what this dimming might mean for our understanding of the cosmos. You see, when a star gets dimmer, it could be a normal part of its life cycle, and there are many reasons why this might happen. But there's the big event called a supernova, which is like a star's grand finale when it's supermassive. Interestingly, there's a link between dimming events and the possibility of a star going supernova. Many stars that eventually explode as supernovae first go through a phase where they become red supergiants. During this time, they might flicker or dim temporarily because of some complicated things happening in the outer layers of the star, like pulsations and changes in convection. Some smart astronomers have been keeping an eye on red supergiants, thinking that if a massive star is about to go supernova, it might start acting a bit weird. But predicting this is hard, and not every time a red supergiant dims does it mean a supernova is coming. Sometimes, a star's dimming is just part of its natural ups and downs. And for Betelgeuse, we're not completely sure yet if that's what's going on. Finding signs of an upcoming supernova is tough and uncertain. But, let's just imagine for a moment, what if Betelgeuse's dimming was because it was about to go supernova? Could a star bounce back from the edge of a supernova? Well, sorry to say, but the answer is no. Once a big star gets to the point where it's almost ready to explode in a supernova, it has pretty much used up all its nuclear fuel and gone through some major changes in its core. These changes make a supernova unavoidable, and there's no known natural process that can turn things around. A massive star starts its life as a main sequence star, where nuclear fusion in its core turns hydrogen into helium, giving the star energy to resist collapsing under gravity. As the core runs out of hydrogen, it squeezes and heats up, causing helium to fuse into heavier elements like carbon, oxygen, and more. This process keeps going until iron forms in the core, and when iron shows up, it's like a cosmic red flag. A supernova is on the way. Once a star gets to this point, there's no reversing it. Iron is quite different from other elements because it can't produce energy through nuclear fusion like the rest. Instead, the iron core keeps getting smaller and gathering more stuff. When this iron core hits a critical point called the Chandrasekhar limit, it can't hold up against its gravity anymore. So, the core collapses fast, causing a massive explosion, a supernova. This explosion is unbelievably powerful, shining brighter than entire galaxies for a short while. It's so intense that it destroys the star completely, leaving behind something dense like a neutron star, or if the star is supermassive, a black hole. Once a star gets to the point where it's making an iron core, there's no turning back. The supernova is on its way, no doubt about it. So, if any dimming stops or reverses, it's because it wasn't connected to a supernova. With that in mind, let's dig into a more sensible explanation for what might have happened. Among the many theories trying to explain Betelgeuse's great dimming, the latest findings provide a more sensible and simpler explanation. A team from France's Université Côte d'Azur observed Betelgeuse intensely from December 2018 to December 2020 using the powerful MATIS instrument on the European Southern Observatory's Very Large Telescope Interferometer in Chile. In October 2023, this team put forward a groundbreaking idea that changed the cosmic story. They discovered a cloud of dust, almost like a ghostly covering, that had hidden Betelgeuse's brightness from us. This dust, made of silicon monoxide, had come out of the star itself, covering its shine. They figured out that the star getting dim wasn't a sign of doom but a natural thing linked to the star's surface suddenly getting cooler. These findings also supported a theory from 2021, which suggested that Betelgeuse had a sort of cosmic burp when gas burst out from its surface because it got really cold. This gas turned into solid dust that surrounded the star like a ghostly cocoon, making it look darker. Here's something interesting. Dust clouds like these around big stars can create entirely new star systems. Let's talk about the big issue everyone is thinking about. The question of whether we'll get to see Betelgeuse explode into a supernova is like waiting for a cosmic show, but it requires a lot of patience. When Betelgeuse had its great dimming, astronomers and star enthusiasts were excited, wondering if this was a sign that the long-expected supernova was finally happening. But here's the twist. None of this is happening right now. All of these events are in the history books of the sky. What we saw in 2019 occurred over 600 years ago in the life of the star. As of now, Betelgeuse is back to its usual brightness, suggesting that its supernova moment might still be far away, perhaps centuries or even thousands of years in the future. The unpredictable nature of star life makes it uncertain when Betelgeuse will finally go supernova. Most scientists think it's still in a phase where it's burning helium, hinting at a spectacular cosmic event yet to unfold. Evidence from Hungary's Konkley Observatory, led by Kenichi Nemoto, supports this exciting idea. But, wait for it, there's a thrilling twist. Dr. Hideyuki Sayo proposes a bold theory. According to him, Betelgeuse might be in its carbon-burning phase, a stage that could lead to an implosion within a few decades, not hundreds of thousands of years. That time difference is mind-blowing. As we await Betelgeuse's grand finale, whether it's a slow-motion cosmic show or a blink-and-you'll-miss-it event, the night sky is gearing up for a colossal celestial display. When Betelgeuse eventually reaches the end of its life and explodes into a supernova, it will be an awe-inspiring and transformative event for stargazers. The explosion of a massive star like Betelgeuse is a powerful process, resulting in a supernova, an incredibly energetic event in the cosmos. Here's the exciting part. The supernova will emit a powerful burst of neutrinos, tiny subatomic particles. These neutrinos will race towards Earth before the visible light from the explosion, although there won't be a significant time gap before the actual dazzling show begins. Amidst all the guesswork about how a Betelgeuse supernova might look from Earth, astronomer Andy Howell from the University of California, Santa Barbara, wanted more precise details instead of just rough guesses. So, he got UCSB grad students Jared Goldberg and Evan Bauer on board to make super detailed computer models of how the star's final moments might play out. While there's still some uncertainty about exactly what will happen during the supernova, the team got better at guessing by studying supernova 1987A, a big star explosion that happened relatively close to us a while back. No need for people on Earth to worry, though, the explosion won't cause any harm. But boy, will it be a sight to see. Goldberg and Bauer's research suggests that when Betelgeuse finally blows, it'll shine almost as bright as half of the moon for more than 3 months. Andy Howell describes it as a super intense burst of light, almost like a super bright torch in the sky. It'll be so bright that it could cast shadows at night and be visible even when the sun's out. No way anyone will miss that spectacular show in the sky. For about a year, this supernova would shine so bright that we could even see it during the daytime. At night, it would continue to dazzle us for several years before gradually fading away. Sarafina Nance, a grad student at UC Berkeley who knows a lot about Betelgeuse, says that when it's all done shining, Orion's left shoulder might look like it's missing. Don't worry, though, Betelgeuse is quite far away, about 724 light-years, so there's no danger from the explosion itself. But even from that distance, there could be some surprising effects. Astronomers like Howell think it might mess with things a bit, like confusing animals that rely on the moon for navigation and making life tougher for astronomers who need darkness for their observations. Howell points out that when the moon is bright, studying the stars gets harder. So, with this supernova's brightness, it looks like there won't be much dark time for a while in the world of astronomy. Studying Betelgeuse itself presents a big challenge because it's incredibly bright. Normal telescopes, whether on the ground or in space like Swift or Hubble, wouldn't handle its brightness well. Astronomers would have to tweak their instruments to handle all that light. But here's the exciting part. If Betelgeuse decides to explode while we're around, scientists think they'll get a heads up. Instruments here on Earth could pick up signs like neutrinos or gravitational waves about a day before the explosion happens. Can you imagine the scene? People all over the world eagerly wait for this cosmic event, feeling excited and cheering as the show in the sky begins. Howells pictures this grand anticipation and the shared thrill of watching such an extraordinary cosmic event unfold. But what happens after a star like Betelgeuse goes supernova? As we stand on the brink of the Betelgeuse supernova, it's like we're in a front-row seat for cosmic history. But what's going to happen to this star? Well, there are a couple of possibilities. One scenario is that the core collapses, giving birth to a neutron star, a super-dense and fascinating object. Another possibility is that Betelgeuse's core becomes so massive that it forms a black hole, a place where even light can't escape. A neutron star is seriously dense, squeezing about 1.4 to 3 times the sun's mass into a space about the size of a city, roughly 12 miles wide. It's mostly made of neutrons, those tiny particles inside atomic nuclei. On the flip side, A black hole is even denser with a gravitational pull so strong that nothing, not even light, can break free. That's why they look pitch black in the sky. They don't give off any detectable light. We're not sure which path Betelgeuse will take. But studying it and its upcoming explosion isn't just about witnessing an incredible show. It's about unlocking the complicated processes that rule how stars live and die. Understanding this celestial event will teach us about how stars evolve, how elements form, and the ever-changing nature of our universe. Betelgeuse is like a unique lab in this huge cosmic theater, giving us an up-close view of one of the most powerful events in space. In this cosmic drama, we need to be patient. Betelgeuse might be unpredictable in its cosmic timing, but it reminds us of the profound mysteries waiting for us in the night sky. So, as we eagerly wait for the Betelgeuse supernova, we stay curious and watchful. When the moment comes, it'll be a spectacular cosmic show, one that'll teach us things that reach beyond time and space, reshaping how we see the universe. Do you believe the Betelgeuse explosion will significantly alter stargazing experiences worldwide? Let us know what you think in the comments below.